sit down. Hey, good to see you. Really? It's all good. Hello, welcome, welcome, welcome. Really good to see everybody. What? Is that a volunteer? Volunteer to do a speech? Yeah, it's awesome to see everybody again. This is the first Cloud Native London that I've been to since October, so I'm actually excited to be here as well. I hope you all had a great Christmas, a great New Year. Looking forward to 2020. So, this is me. I'm Cheryl. I'm the Director of Ecosystem at the Cloud Native Computing Foundation, which is the foundation that hosts Kubernetes, Prometheus, Envoy, and lots of other things. I'll be tweeting tonight using the hashtag CloudNativeLun. The Wi-Fi password, you have to use O2 Wi-Fi, and then it will send you a text message, and then you have to sign in. So, bit of a pain. Sorry about that. If this is the first time you've come to Cloud Native London, then especially warm welcome. Cloud Native London is a strong, open, diverse developer community around the cloud native technology and platforms in London. So tonight we have 3 speakers. So at 7:15 we will have Chris, who somebody's excited. Oh, hello. Who's going to talk to us about rethinking security, container security. At 7:45, we have building a crypto bank in the cloud from Hussein, who's getting mic'd up. And then 8:15, we'll take a short break. And 8:30, we'll come back here. And Victor, who is also there, is going to talk to us about DevSecOps. And then after that, at 9 o'clock, we'll finish up and we'll go to one of the pubs around the corner from here. A couple of shout-outs for tonight. So thank you. These are the people who pay for the pizza and drinks. So Technovo folks, do you want to say a word? Go, go, go.
Hi guys, Kevin from Technovo. Keep it short. Essentially, for those of you who don't know us, we are a challenger consultancy. Help organizations go through digital change. So pretty exciting year for us here. If you want to hear more about a little bit about the things we're doing, then yeah, feel free to grab one of us. We're lined up on the side and we'll be in the pub afterwards. So,
do you want to do
cheers.
the Meetup Mates
somebody will be doing the Meetup Mates. Kat, if you want to say a word.
I love this initiative.
Getting my steps in. Hi, I'm Kat. I'm from Meetup Mates. I also work with Cav from Technovo. But Meetup Mates is a community we run predominantly on Slack, and our purpose is to bring together people who attend meetups just like this. If you want to join us, it's meetupmates.com, and we love to meet new people. Thanks.
Cool. Thank you. And just to clarify, Meetup Mates is particularly aimed at people who go to meetups by themselves and maybe don't know anybody and are maybe a bit nervous for their first time. So they get together in the pub beforehand. And actually, did anyone go to Meetup Mates from here? Yeah. It's like 5-10 people. So yeah, that's Meetup Mates. Any folks from Contino here? Is that a hand? No. Want to do an introduction? Okay. Pusher. Okay. X Matters. I know they're not here, but yeah. Okay, so I'm going to move on because we actually have quite a few sponsors. This is the sponsors who like to lay out their logo like horizontally. These are the sponsors who have square logos. So Humio, anyone from Humio here? Okay, Palo Alto Networks. Yes, come and say hello. Yeah.
Oh, thank you. A clap. Who was here last month, by the way? A couple of you. So you may remember our talk was the last one. The slightly energetic presenter at the end was my colleague. Actually, well, the brand that we work within is actually Prisma within Palo Alto Networks, and it's all about security for your cloud-native workloads and the cloud. So, yeah, we're the security guys. Thank you.
Okay, anyone from SUSE here? No, okay. And D2IQ, formerly Mesosphere. Okay. In that case, I'm going to move us onwards. If you want to come and speak, we're actually now completely booked up for the rest of 2020. So you can go to this URL, but maybe think ahead for next year. And that is the end of my slides. So with that, I'm going to hand over to Chris. Please welcome, round of applause for Chris.
You need to fill while we change laptops. Right.
This is the moment when I stop to take a selfie with people. So you guys have to wave and look excited to be here. Okay? Smile. Okay. One of those will be good, I hope. Thank you very much. Oh, and for questions afterwards, I'm going to run around with this mic because this is being recorded. So if you have questions, please raise your hand. I'll come round. Thank you.
So, welcome everyone. Thank you for coming. And I have got till half an hour-ish to talk about rethinking security from scratch. So let's kick off. Agenda. So who am I? Welcome everyone. I live in the UK. I've spent the last 6-ish years playing around with Kubernetes and containers and Docker and anything else in that kind of sphere, but mainly with large financial services organizations. So I have a very strange view of the world, which is I love the technology, but I can't use it because the security and compliance people tell me I can't use it. Is most of the time I find myself in that kind of dichotomy. So I also play hockey badly. I'm getting older and slower. It used to be great fun when I was playing hockey, and you know the new players in the team were at half my age. I'm now in a team where there is a player who is a third of my age in the hockey team, at which point I'm starting to think, yeah, this is getting a bit harder. But anyway, what inspired the talk? So I'm going to ramble on for the next half an hour-ish about containers, scratch builds, how to make the smallest possible container image, and why you shouldn't do it for people and process reasons rather than technology reasons. So I had a look around, and I was like, who can build the smallest image? This man here. I used to work with him in his Barclays days. 1,000 bytes for a container image. Here's Kelsey saying, keeping container images small. And actually, you know, there are good reasons for keeping container images as small as possible. When you actually warm that image, when that image has to be cached to the node that's actually running your containers, be that on Kubernetes or any other orchestrator you have, that is going to take time to pull over the network. So there are good reasons for keeping your container images small. I'm not saying not to do this, but I'm saying that this quest for the thinnest, smallest, tiniest container image is maybe something that's not something I buy into, and I'm going to try and argue that case for you tonight. Yes, you can read that. So where did I go to? How did I kind of go through the talk? And I'm going to take you through my journey. First of all, though, I need to do a bit of a refresher, because this might be teaching your grandmother to suck eggs, or it might be telling you things you already know, for anyone who's not familiar with that kind of idiosyncrasy. But let's just have a look at kind of container images and how they're put together. So this is from the Docker man pages. Oh, I forgot to say as well, if anyone wants the slides, you don't need to take pictures, or the videos with the demos on, or the Docker file, or the bits and pieces that I'm going to go through. I slapped them all up on GitHub today, and there's a link at the end. So just take a picture of that slide, and you'll be able to get all of these slides and all of the things as well. I've got to say that, very important at the start then. So this is kind of how containers are put together. We start with these things called layers, and if we build layers of other containers, we build a Docker file, and we do from. That might pull in one of these image layers, and we might build and we might layer other components on top of it. I think everyone's kind of familiar with how that works and with that concept, I'm hoping. Anyone looking at me blankly? I think the whole room's with me there, so that's good. So really tiny font, but if you are really good with your SHA-256 sums, you've computed them in your head, you can see that this layer here on the left-hand side and the right-hand side are, well, basically I've highlighted in red, they're the same. So if you go onto a box and you pull an image, like for example Alpine Lattice, CentOS Base, anything you want, Fedora, whatever you want to pull, and then you pull one of these languages or one of these build packs or one of these kind of components on top of it, what you find is this thing inheritance. So those layers back in that picture before, your machine will go, I need to pull this container, and this container is made up of these images, and because you've already pulled that image, I'm not actually going to transfer anything over the network because I already have this layer cached on my local machine. So you can play around with this. If you do go onto a machine, start a fresh machine, just install your container runtime of choice. I'm going to say right there. You pull that image on the left, and then you pull that image on the right. When I pulled that last, there were 5 layers in that image. Only 4 layers were pulled because that image on the left was already a base. It was already a layer that already existed on the box. And it's really interesting if you do a Docker inspect and you look at the actual layers, you actually find the reference to the overlay2 file system directory. Tends to be the way that most Linux distributions are kind of layering their layers in there. And you can go into these file systems, and you can actually mount these file systems, and you can see what people were doing when they were building that container image. So this one here, the Golang Alpine, if you go into the 5th layer, the 5th and last layer, you'll actually find the Go, the source. You actually find someone actually unpacking the latest Go, following basically the install instructions from Google's Go website of how to actually install that. And you can see the individual kind of changes people made to their containers as they were building that up. So that's just a quick primer to say, this is how container images work. Hopefully, many of us have had to play around with this. Probably many of us played around with this about 4 or 5 years ago when Docker first came out, and we were playing around with this, and we've kind of maybe forgotten it. So hopefully that's something just interesting just to kind of refresh that stuff there. So back to my first challenge, which is how do I build the smallest container image possible, and what are kind of my options, and what should I be looking at as kind of good practices? So the two that really kind of seem to be the ones that are kind of the standard are these two around distroless and this other one, which is Scratch. And this is what I'm going to try and argue is I'm almost thinking Scratch is an anti-pattern and one to be avoided, but I'm going to try and argue that, and you can make up your minds afterwards, so we'll see where we get to. So the first one is distroless. This is just using Docker builds, so Docker multi-stage builds, which came in about Docker 1.7, I want to say, but my memory's not quite. It's after Christmas. There's lots of pudding and wine and things, so I think that was about the right phase. So I'll have to go and look at the change code. But what we have here is what's got a multi-stage Docker file. So we want to install a Linux machine, which we're going to be doing these builds on. So we install our Linux machine. We want to install a Linux machine, but we might want to build Go, we might want to build Rust, we might want to build Java, we might want to build all these languages. So what we don't want to do is we don't want to build a massive bloated machine which can build every language. So what we'll do is we'll say, well, actually, rather than install development kits onto my base image, I will actually have my build capabilities in a container. But back to my kind of banking hat and thinking about regulation, if you say to a bank, can I then put my compiler into production, the answer is no. When you go to production, you need to have nothing on there that people can then get onto the machine and compile their own binaries and stuff like that. So thinking about security, thinking about these layers, how do we then have, well, we want to have a container which can build code because we don't want to pollute our base Linux machine with that. But we want to have a runtime which contains just enough runtime to run that application and doesn't actually get us into any problems with security, compliance, audit, PCI, DSS, any of these other regulations we've got to sign up to. So what we do is on the bottom left, we have a base operating system. We then pull a container, so from Golang. And the nice thing about this is you can give it a named reference. So in here, I've called it as builder. So I've given it a human-readable name, so you can kind of follow what's going on. Basically, it's going to pull some Go code, pull it from GitHub, because that's the safest thing to do with all your code, of course. We're going to then inject that application that we built, and we're going to have that basically, completed binary artifact in that container. Then we're going to pull a runtime. So Go is, we can build self-standalone binaries. We don't have to have any dependencies. We can basically build standalone binaries with Go, as everyone knows. Or do they? Anyway, we'll get to that in the next slide. So we can then inject that standalone binary into our runtime container, and then we can run that. Brilliant. So really nice kind of two-stage separation of duties between build and run. This is my preferred approach from me, but I'll come back to that later on, still in the punchline. The one that kind of has got a lot of traction, a lot of interest, has been this from scratch. So from scratch basically just creates an empty layer in that overlay file system. So it basically creates, here's a container with nothing in it on the file system. So we can, on our base machine, if we want to, we can actually create a binary, a standalone binary. So in this case, the traditional hello world. We can use a Docker file, this is just a box standard Docker file. We can inject that hello world binary we've built with Go standalone on the command line. We can tell it what to do, and we can then say, right, there's nothing in that layer apart from a binary. So I thought, right, this is going to be the way to make the smallest file possible. And I'm still talking about technology here. So I'm talking about technical capability. Bear that in mind as I come back to the end as well. The one thing to remember with this all, of course, is that, back when I think we had the very first releases, there were bits missing in the Linux kernel. So there was no, I think it was PID was one of the namespaces that was famously missing. So if you forked 10,000 processes in your container, you could create a fork bomb, and you could basically stop, Linux had a U limit on it, which would basically stop you creating any more processes. But over the time, they've basically timed up the namespaces. So there's namespace isolation, so your process, your network, all of these other components in there. Your control groups, you've got richer control groups around things like storage and networking. And they've added some other capabilities in there. So kernel capabilities, so setcomp profiles, so capsysadmin, capsysnet, all of these other kind of components where we can filter out your capabilities. And then there's been this push around Linux security modules, so things like AppArmor, SE Linux. How do we then isolate your container? So if we are going to create a from-scratch container, and we're going to only inject a standalone binary, you have no ability to see anything on the underlying file, underlying container host there. That's the whole idea behind this. So just pointing that out, because this kind of went wrong a bit. So, demo, the Wi-Fi here is a bit iffy, so hopefully I did the sensible thing and recorded it, but I'm not sure how it's going to look, so we'll try that, and if not, we can spin up Oh, why is that all fuzzy? Hold on a minute. No, still on the Wi-Fi. 1080, there we go. Let's try that. So, is that in any way visible at the back? Not at all. Right. What was I typing recently? What was I looking at my public ID? Right, let's have a look, see. Right. I've got the speaker notes on here, so I haven't mirrored the screens, so this is going to be a little bit of a typing test. Bear with me for 2 seconds. Right. This is the directory that I'm going to look at. I'm actually going to take you back to the video and kind of talk through that once I've shown you the files. I did put the ones that are useful on GitHub, so you can go through this and play around with it. So the first one I'm going to look at is just this code here. I'm not a developer by trade, so I just looked for a really simple bit of Go code, which would be completely standalone, isolated, static. And all it's going to do is listen for an HTTP request, and then it's going to return a simple line of code. So I thought, brilliant. This is the simplest program I can find to run. What I'm then going to do is I'm then going to do a go build dot. I'm going to build that binary, so that Go code, into a Go executable. And this is just stock, I think it's Ubuntu 1910, so I just pulled the latest version running in this container. And the Go compiler was just the one, I just followed the instructions on the Go website how to install it. So I'm going to build that Go binary, go build dot, and then I'm going to do docker build dot. I've got the latest Docker 19 point whatever it is installed on the machine. So that's going to produce a binary called hello world, and I'm going to inject, so you see from scratch at the top of this Docker file. So I'm going to create a layer with absolutely nothing in it, and I'm going to inject that binary into that application. So let me go back to here. So ignore, now I'm just showing you the code. The videos, these are, I thought it would be 1080p, so I did kind of shrink it down, but I need to do it a bit more next time. So go build dot, tell you what's going on. So the green thing is the executable binary that's been built. I run the binary standalone, just to show that, so nothing on the page, and then you can see the website came up. So just a simple static file, kill the binary, the website disappears. I'm then going to run, look at the Docker file, look at the information in there. I'm then going to run a docker build dot, which is going to just, it's going to read the Docker file that it can find in that directory. It's then going to create a containerized image. And I ran this, and successfully built, and I'm going to show you the images on there as well. They're about 7.3, 7.6 megabytes. So it was slightly bigger than I thought, given the code. And I've gone back to there. That's not what I wanted to do. Google Slides, you're killing me. And I got to this point here, and I got this, it basically bombed out with an error. And it said, unable to find file. And I went, what on earth does that mean? And I wasted about 4 hours of my life searching on Google, and nowhere on Google does it tell you this. And in the end, this is a cut and paste from Google Book Search. I figure I'm okay to show it because it's a Google book. But basically what it says is, when I did LDD against that binary I built, it said, oh, you're linked to the glibc. And I went, what? I didn't ask Go. I thought Go produced static binaries. What are we doing here? Turns out, if you build Go, and you don't say build a Go program for multi-architecture, you say build Go on Linux for Linux, it decides that like the pthread library and other things in this text here are better than the Go implementation, so we'll just link the C runtime into your Go executable. That's 4 hours of my life I will not get back from playing around with that one. So I was like, right, okay, we're gonna fix this. So we tried again. So what I did is, this is my FFmpeg. Oh, don't do this. Google Slides, just show it, right. If you export CGO_enabled equals 0 as an environment variable before you build your Go binary, it will build a Go binary that doesn't link to the C libc on your machine. I was like, yes. So we ran through this. What you'll see here is basically, you can't read it, but the videos are up on my GitHub, and I've got the link at the end. Please do go and watch this. You'll see that we actually managed to containerize my little application, and my application runs, and I start that static web page. I'm like, hurrah! Technically, brilliant. 7.5 megabytes of really tiny code. I've built the smallest container image, you know, gigabit network, 10 gigabit network. We're talking less than a second, you know, a second to pull this over a 10 gig network. Brilliant. Operationally, useless. This is my argument with the whole thing to this. So, you know, 1,000 bytes for a container image, great, but how do I actually introspect this? So I'm going to skip on to this one. So here you go. You'll see that if you look at the videos online, 7.39 meg for the one that doesn't work. Sorry, the one that does work, 7.45 meg. So if you don't link glibc, you get a smaller binary. Makes sense. But that's me running one container. When I go and talk to, you know, banks and other large organizations, they're like, yeah, we've got 600,000 cores, we've got 1 million VMs, we've got data centers in every continent of the planet. We don't remember what we did yesterday when we were playing around with this stuff, and we don't remember what we deployed. So great, you've deployed the smallest possible container image, and it's just a static Go binary in there. I'll come back to it a week later. What did I put in there? Let's try and run that container image with the shell command. Let's try and get a shell in there so I actually see what I put in that container image. Yeah, that doesn't work. Executable not found. Oh, I've got, you know, if you say, you know, one physical machine equals 10 VMs equals 100 containers, I've got 6 million containers running in my large financial services organization, and I've got no idea what I put in there. And my current pattern, which is I trust the edge. So what do? I go and download a security scanner. I put an agent onto all of my machines, and my agent collects data, and I inspect the running state. That's the pattern we've grown up with in physical machines and virtual machines. Doesn't work. I found one thing. This took me about a day of your favorite search engine, insert name here. I found that you can run your binary in GDB, so the debugger, and you can get the version of Go that was created in there. That's the only thing I found I could get out of this binary. I gave up after this. You probably get more out of it if you know how to reverse engineer code, but I was like, no. So when you look at our current security model, how does it work? So there's a CVE. CVEs are linked to, has anyone seen a string like this? And it starts CPE. CPE, I didn't know this, I learned something new doing this research, is Common Platform Enumeration. And if you search for this string in your package manager favorite database of your distribution, this CPE string should always match the code, the package that has the vulnerability. Okay, so I've got a vulnerability in source code, but I always map that back to a package. Well, it's worse than that, because actually what we've been used to in the VM and physical server world is we actually map that back to a distribution. That's what we do, and that's what we trust, because we have a supply chain, we have other people in our supply web. And then you go up to the top and say, so you've got the security teams coming to me and saying, actually, you need to patch all CVEs within 1 month. So we've got a process that maps a CVE to an OS level or a package. And the problem I've got now is I can't introspect what I deployed because I put no tools in there. I put nothing in there. I just put the application binary that could run. So suddenly my edge-based model, where I introspect what's running, is completely broken. These links are in the slides. Slides are on the GitHub page. I'll show you the GitHub link at the end. Fantastic blogs that I found really interesting to read, and I really recommend especially this Polyverse one here on the bottom right as you look at it. But on the top left, the Cloudflare team basically said, those labels that you embed into a binary at compilation time in Go, we actually enrich those. So we actually have things like what Git commit we pulled your source code from. We have things like what feature branches were alpha beta stable, what versions. We actually put a whole load of metadata into our binaries, so you can run the Cloudflare DNS application with a -v command. It'll dump out all the information. So you can go into your container, or you don't even need to go into your container. You don't need shell or anything in there. It's still a standalone binary. But by running that container with the executable -v, you can dump out all the information. And this one on the bottom right basically said, our whole concept in our mind where we think about operating systems, applications, versions, whether this incrementing level of semantic versioning, so 1.0, 1.1, 1.2, 1.3, you might have a feature branch that you build for one customer that you throw out there. Nothing is true because you might be on a different branch to the master. You might have some code that's thrown out there that's not actually stable. So how do you map everything back? And my research to date says we've had a lot of work and open policy agents. People, loads of talks about that. Everyone familiar with that? Hopefully so. If you're not, go and have a look at it, because there's rumors that pod security policy will be deprecated. That's kind of the thing going around. But all the work around OPA is around admission controllers. So I have a Kubernetes cluster of hundreds of nodes running thousands of containers. And what I will do is I will run an admission controller that says you are not allowed to deploy your code if it contains a vulnerability. But actually, what I'm deploying, you can't introspect because I have no tooling in there to introspect, given our current patterns. So what I'm expecting to do, and it's a bit of an anticlimax here because I'm actually saying there's no good solution yet. I'd like someone to come and ask me to come and help build that with them, if anyone wants to employ me or my company to do that. But anyway, but there's a kind of a gap here, I think, which is basically says what you need to do is you need to trust the build system. And as you build your binaries, you need to build kind of a table here, and you can extend this table back to like the Polyverse blog and say, actually, the features in this version of this binary that we're embedding into this container map back to the SHA-256 sum of the container. I built it from Go 113.4. When the Go 113.4 vulnerability comes out, I can run, a custom controller to go into my cluster and actually say, which containers are running based on this SHA-256 sum, and then I can actually annotate them, or I can put a label on them, and I can do something to actually say, we now need to go and either alert people, if it's running in production, because we're not going to take production clusters down. But if it's in development, we might want to stop a cluster, or we might want to force a next build. We might want to run the pipeline again to actually build a new container image. But the biggest thing for me for this is that my kind of experience in regulated industries, I need to go back to the people who are used to running an agent on a VM, an agent on a physical box. And I need to say to them, you won't be able to introspect your containers because, one, if we're going to build the smallest container possible, it's not going to have the metadata in there that you're used to inspecting. You need to actually trust the build system, and you can sign them, do whatever else you want, but actually you need to move your trust to the build system away from looking at what's actually running in your estate. And my hope as well is that if we release early, release often, start releasing code faster and faster and faster, people are not actually going to be able to introspect what's actually out there. The containers are going to be changing on so fast. So there's a couple of projects which kind of aren't doing this yet, but are kind of focusing in this kind of area. So there's the Open Policy Agent, there's the InToto, which is more focused on signatures. But in my mind, we need to, we've got a CVE feed there. So we've got a CVE feed. We're collecting, in our build database, we're collecting a lot more metadata about what we actually built. And then we can run a query, when we get a new CVE, Go 1.13.4 has a vulnerability against it. Can you go and tell me all the containers and all their SHA-256 sums that you built, that were built using that version of the Go compiler? And then we can actually say, right, they're vulnerable to CVE 1234-5678. And then we would have a custom controller which could then go through and actually annotate all of our pods and all of any of the thing running in the cluster and actually say this is the thing that we want to get rid of. So, in summary, and I think I've got no time for questions, talk too long. But I'm around, I'm going to hang around anyway, apologies. But in summary, why is building the smallest container possible without any of these introspection, metadata tooling, any of that, why is this actually an anti-pattern on the people and process side? Technically it's possible, but think long and hard because you're going to have to sell this to a security team if you work in any of the regulated industries, which is where I'm used to working. Got no time for questions. I'll say one question.
So I'm going to challenge you on the if you use the pattern that you described, where you have a build container to build your static binary, to make this really safe, you would also need to have deterministic builds for that binary, and you would need to encode that information in your version info in that binary, because otherwise you could get like some security flaw introduced by the way you built your binary. Like, have you thought about that? Like, what is your suggestion for doing that?
So I think that's more of I think that's kind of a maturity model thing, where you start with saying, here are my build containers, which are the ones that you can only use these build containers because I've run them through my traditional process and everything like that. Deterministic builds, I can change the compiler, I can change the code, I can change, the operating system. I can change anything. I think that's a bit of a misnomer. I think it's more about actually building a better picture and chain of trust on all of those components to actually say, I don't care about determinicity in the sense that the SHA sum has to match exactly. I just know that I'm following the right process and no gremlins. And the security vector attack of approach that seems to be the most common one is people are actually trying to say, well, if we attack the build system, we can infect everything at once. So for me, it's a massive focus on this area and actually hardening that rather than worrying about, do I get the same sum at the end of it? For me, I'm more worried about the outcomes. Cool.
Okay, thank you very much, Chris. Round of applause, please.
Good.
I'm looking for our second speaker, Hussein. Hello, do you want to come on up and put your laptop in? And while you're doing that, I'm actually going to retake the selfie because I wasn't happy with it. So you guys have to like actually wave and show a bit more energy as well this time. I'm going to try and get more people in as well, which is why I'm doing it from the corner. Okay, so get ready. Okay. Okay, that's better. Okay. Ready? So 1, 2, 3, wave. Okay. Thank you for the benefit of Twitter. Yes.
That'd be great. Thanks, Joe.
Sure.
Marvelous.
Okay, and so how many people here, this is the first time that they've come to Cloud Native London? Oh wow, good number. Probably about a third of people. So, very cool. That's always nice to hear. How many people have been here like up to a year maybe? Like 1 to a year maybe? Okay, about a quarter. And then how many people have been here like longer than a year? Okay, about another quarter, maybe a third. Okay, awesome. That's good for me to know. Looks like we're all set up. So, Hussein, are you good to go?
Almost. I hate technology. I do apologise. This is PowerPoint on a Mac. Really.
Okay, I will leave you to it. But in the meantime, please, a round of applause to welcome Hussein.
Thank you very much. I don't have F5, so, you know, the wonders of technology. So, why? Are you denying this on that side? Okay. Let me have a look. Yeah, it does work. Who would have thought? Sorry, I'm in a startup at the moment, so very little works without a lot of bloody effort. Chris and I know Chris from our Deutsche Bank days. We worked together on the digital transformation of Deutsche Bank, and he was working for Red Hat at the time, and I was working for DB. So, a bit of background about myself, very briefly. I've been in financial services for about 25 years, more or less, in IT. Deutsche Bank, Vocalink, Bax, Wave Money, U Technologies, and just got back from Myanmar about 9 months ago and got the opportunity to work with Mark Hipson, co-founder and CTO of Starling, and he set up a new venture building a crypto bank in the cloud. So Chris was talking about building Docker containers from scratch. I'm going to talk about, it's not going to be very technical, but I'll talk about how to build a bank from scratch in the cloud. So there's a tenuous segue for you there. Okay, let's start with this. As you can see, my slides are more kind of startup slides. I don't have the backing of VMware to format them brilliantly, so it is what it is. A little bit about Ziglu. Very briefly, we're essentially offering best price crypto and fiat currency exchange. We're trying to allow our customers to make payments using crypto and digital currency seamlessly anywhere. And we're offering all of those services eventually globally, but starting in the UK. So it's a digital challenger bank, bringing together. It's been called the love child of Monzo and Revolut. I don't know if such a thing exists, and I don't know what that would look like. I prefer to term it as kind of the future of banking. Keep it simple. Now, I was told, we have our heckler. Excellent. This is brilliant. Thank you for coming along. So, I was told that there should be 3 takeaways for this presentation, and I thought, well, let's do it at the beginning, and then hopefully you can see how these takeaways actually work in terms of the process that we undertook to build the bank. And my talk is just about sharing experiences with you guys. I absolutely welcome feedback from the audience as well, so this should be a contentious discussion. I'm bloody opinionated, and I'm more than happy to have other people criticize my opinions. So what I'd like you to take away from this is three things. 111, they're all bloody important, obviously. Finding the right people is the biggest factor in determining success. So people, process, and technology, people are the #1 important thing. Good people can deal with bad process and bad technology. The reverse isn't true. Taking risks on a greenfield site, especially, so Ziglu is a startup, it's a greenfield site, it was an opportunity for me to take a bunch of ideas and practices that I'd seen work in the past, or that I'd done myself, or I'd seen other people make a success of, and apply them freely. So risks are unavoidable. My suggestion is, take the ones that offer the biggest upside against the smallest downside. Trying to be risk averse isn't a good policy, in my opinion. Take risks and make sure they're going to pay off really well when they work, and if they blow up in your face, you don't get sacked. Finally, make sure all of your decisions are informed. God, it's easy to say, very difficult to actually execute on. Informing a decision means you don't take it on your own, #1. Involve other people in the bloody process. It's good governance. Whoever has decision rights at the end of the day is accountable for those decisions. But make sure you involve people, give them input rights into that decision, and share the risk. The more you can share the risk, I think the downside can be controlled and the upside will pay off. So hopefully these 3 takeaways will permeate their way through my appallingly formatted PowerPoint presentation. The first thing I did when I joined Ziglu in May was to talk to the nascent team that I had in place, my head of mobile application development, my head of engineering, senior developer, 1 or 2 other guys, and of course our CEO, who is the CTO of Starling Bank. Yeah? And interesting to work for a CEO who's a CTO, a bloody breath of fresh air, I would add. I mean, it's easy to have a conversation with my CEO and prioritize technology over the rest of the bollocks, because he was a CTO, which is fantastic. I mean, unbelievably good. So we had a choice. What technology are we going to use for our mobile application? In the end, we went with Xamarin for the reasons that we had a high level of expertise in-house, because it's written in C#, and I'm not a big fan of C#, but we had a decent level of expertise in the house. It would require fewer resources and development effort for building native and iOS and Android applications. Otherwise, I'd have 2 separate teams, 2 separate processes that I have to manage. In a startup with limited resources, I don't have that luxury. So being able to have a cross-platform capability of deploying to both of those platforms is a big plus. But it's not necessarily always the right decision. I'm talking about startups, greenfield sites with limited resources. And finally, it was the least cost of change, because financially and temporally, because it's the incumbent technology. Now, having said all of those things, we did go through a selection criteria, try to inform our decisions. So all of us, in this case, like red, black, green and blue, are different individuals in the team. We just scored them based on some criteria that we as technologists thought were important. Performance, security, vendor support on the technical side, and also some business criteria as well. It's not a complete list of criteria, but it just demonstrates the process. We got around the board, the whiteboard, what's important. Just mark them off. These are experienced people, 10 to 15 to 20 years of experience in the field. They know what they're talking about. I depend on my heads to inform my decisions. And we scored it out, and in the end, we chose Xamarin, probably unsurprisingly, against React Native and going native. Going native really was an option. I couldn't afford to hire enough people to do that, maintain 2 separate teams. React Native was the only contender. There was no one on the team that already had those skills. So, I mean, Xamarin had a big head start anyway, but we went through the due diligence of executing this process. What were the positives? Well, actually, hiring for Xamarin we thought was going to be difficult because you've got Android and iOS developers are two a penny. Xamarin, I'd never bloody heard of it until I joined Ziglu. Essentially, it was quite easy to hire. So, we scored it low on hiring because we thought no one uses technology, but actually it was easy. What were the negatives? Really appalling SDK support for all of the integrations that we had to do with our vendors. So, we're a bank. AML, KYC, all of these things that you get if you're, any of you are using digital kind of banks at the moment, your Monzos and Starlings, you do everything on your mobile phone. Well, we had to write all of that. None of these vendors provide decent Xamarin SDKs. They're appalling. So, lesson learned. Make sure the third parties provide decent APIs and be prepared to code your own SDK. Fortunately, we had enough good people to be able to do that for the integrations that we were responsible for. So was it the right decision? Well, so far, it's a hell yeah, it was. We're on track for delivery. I love the look and feel of our application. I would say that. We have a friends and family program that you can all join and take the piss out of me for saying that later on if you'd like. But I think it was a good decision. It was an informed decision, and it's working rather well. Server-side language. I'm a Java developer, and Kotlin, I'd say, is like, I love Kotlin. It's brilliant. But having done Java most of my life and worked with a number of other languages, Python, C, and the rest of it, I think Kotlin's brilliant. But we went through the same process. The team lined up, score it based on the criteria, and Python was the #1 choice based on our process, which we reversed with after about 2 weeks and went with Go. I can't bloody believe that Node.js won. So this is the pitfalls, okay? This isn't a rigorous process, but you just got to go through it and be prepared to pivot on your decision quite quickly. Nothing's set in stone. So, yeah, what the fuck? Node scored higher than Go. Can you believe that? Anyway, what were the positives about Go? Easy to get a job in Google, apparently. So, honestly, I can't think of anything amazing about Go. I really can't. I'm sorry to say that. And I worked with Go when I was in Hong Kong building Utrip, which is doing fantastically well now. It's like Revolut clone. Back in the day in Hong Kong, I just remember dependency management was an appalling problem with Go. Shockingly bad. I'm, again, from a Java world, it's Java jar files, libraries, they're easy to bloody manage. Go is just, I don't know, someone made a change upstream in their repo, and half the bloody Go community went down as a result of it, including us. 4 days wasted. Well, that was 2 years ago. Things have got better. I do see a lot of benefits of Go, and I've started to write some Go myself. So, was it the right choice? Probably. But what are the negatives, the big negatives of Go? Forget the language. Let's not get into a religious debate around that. Hiring for Go developers has been one of the banes of my existence. Again, I had this in Hong Kong, and I'm now doing it in London. I thought hiring for Go developers in the city for a fintech should be easy, right? No, it bloody isn't. The preference for remote working in the Go community. By the way, how many Gophers have we got here tonight? Show of hands. If you're looking for a job, you know who to talk to, right? Maybe. So yeah, remote working, almost, I would say 9 out of 10 Gophers that we talk to that make it through the initial interview demand remote working. I'm building a bank. I need the flipping people in the building at the same time. There's a lot of discovery going on. There's a lot of design. We have to make decisions quickly. Remote working, I don't know, maybe 6, 9, 12 months down the line. Maybe. And, it is what it is. Actually, today I hired my first Go developer that we allowed to work remotely. So, we got beaten into that shit eventually. Thank you. Thank you. We do pivot. Lack of financial banking, crypto expertise, not quite. There's plenty of Go developers who have all the relevant expertise. They're all working for Monzo. Fucked if I can hire them. Right? So, I can't compete with that. We do find eventually a few rebels and renegades that will join us, and actually I've managed to staff my back-end team. Fingers crossed, in the next week we'll have a full back-end team of Go developers, but not easy. So again, if we were doing Java or Kotlin, I think it would be a lot easier to hire, a lot easier. And yeah, the current demand for Go developers is through the roof. Why, I don't know. Maybe they all want to work for Google, and that's the real reason why they're doing Go. So jury is out on Go. Actually, I think it's probably the right choice. I don't want to be too harsh on the Go language. But again, we went through this process, and just like give you some of the criteria, you can't read it at the back there. What's the cost of developers? So we've got business, we've got technical, and we've got some use cases, our specific use cases. API management, service orchestration, tooling, security, performance. Took a bunch of this stuff and evaluated it. Just gave numbers, and yeah, apparently Node is better than Go. Cloud provider. So I've worked with Amazon, Azure, and now I've had the privilege of actually working with GCP. I'm sold 100% on Google Cloud Platform. People will hate me for it, but I think it's the best cloud by a long shot. We chose GKE as well, Kubernetes engine, for a good reason. I don't want to install and maintain my own Kubernetes cluster. I get, 3 or 4 years ago, you didn't have a choice, you had to do that. You've got a lot of choice now, and if you're doing that, I think it's a bad decision, you're wasting money. Positives, stable, compliant, and secure. It's easy to terraform. So, I'm big on automation. We terraform everything, absolutely everything. My head of platforms is here. Matt, raise your hand. He does all of our terraforming for us, and he's bloody good at it. So everything's automated, very simple to terraform. You can say it's the same for AWS, I get that, and arguably for anything that has a Terraform controller. But I was still surprised. I did the initial terraforming, and I shouldn't be allowed to do any coding, but I still managed to do it. So if I can do it, sorry? This is from my head of platforms. Right, you're fired. Okay. Plenty of opportunity to look for a job here, Matt. It's fine. And we have, if I can do it, anyone can. In conjunction, now this is fascinating, and actually Matt takes a lot of credit for this. In conjunction with G Suite, it makes hyper-automation possible. And what we mean by that is actually not just when we do infrastructure provisioning, it's mostly automating the provisioning of your core IT. But actually, if you're using G Suite and you've taken the Google pill, you can start automating the provisioning of your corporate IT, which is, for me, I hate corporate IT. I'm a technologist. I always thought corporate IT was a bunch of Windows nods doing whatever they do. The further they were from my life, the better. But now, we're using G Suite, and we can automate all of that as well. So that was brilliant. I call that hyper-automation because I hate corporate IT. Excellent support. I was really impressed with Google's support. I'd raise a ticket, they would respond very quickly. The response wasn't just, get the hell out of my face, you could read the documentation. It was good support, even on the silver standard. And finally, I could actually talk to someone face to face. And, 9 months in Hong Kong, I never met anyone from Amazon who wasn't a salesperson. Now, I know if you get enough, if you're spending enough money with any of these vendors, you can get access to all the support that you need. But again, the context of this talk is a startup greenfield site with limited resources. Google were brilliant. I could pick the phone up, talk to someone, have a conversation with them, and get the problem sorted. So it leaves Amazon in the dust as far as I'm concerned. Negatives. Matt has found this one. A really annoying problem with Cloud SQL, which forces sequential provisioning, takes a bloody long time to provision Cloud SQL sequences. That's the only thing I could think of as a negative. Was it the right decision? Hell yeah, it was. Build tools. I actually spent a huge amount of time on working with Make, Ant, Puppet, Chef, Gradle, and now Bazel. So I like my build tool, so it's key to automation. You're familiar with Bazel Brush, yeah? All right, so that's Bazel Brush. YouTubing, grep the web for Bazel Brush. What are the benefits of Bazel? It's incredibly bloody fast as a build process. I've never seen anything like it. Really impressed. Amazingly broad functionality in terms of the rules, implementations, and what you can do with it. Incredibly terse. A few lines gets a shitload of work done. So Gradle, which I love, I've got no qualms with Gradle, and if you're from a Kotlin world, Gradle is probably what you're using. It's quite verbose. The DSL, domain-specific language, is quite verbose compared to Bazel. Negatives, it looks terrible. Just, I don't know, I do think aesthetically pleasing code is quite nice. If you're going to have to look at something every day on a monitor, day in, day out, it's nice if it looks good. Maybe I'll get used to it eventually, and it's an ugly child that will grow into something a little bit better in the future. But because it's so terse, I find it difficult to... It's got colons and forward slashes and all sorts of crap that I don't expect in a DSL for a build tool. But I get used to it. Documentation ain't great. Learn to use Git. Matt has kindly created a repo that will get you off the ground using the technologies that we use. So Go, gRPC, containerized, with Gazelle, which actually generates build files for Bazel as well. There isn't much documentation, and what documentation there is isn't great. Basically, you have to learn by going and looking at other people's repos, which is what Matt's been doing, and I've started doing the same. Was it the right decision? I think so. I really, you know, as someone who's used various different build tools for a long time, Bazel is pretty bleeding edge and ticks a lot of boxes. Bit of a learning curve involved in it. And then finally, what are the principles that we actually adhere to? Well, what are the principles that I think that are useful in a startup, or frankly, any technology organization? So 50-page book, it's tiny, that I wrote a couple of years ago. No dev, no ops, no IT. Principles governing the ideology, methodology, and praxeology of informed IT decision-making. The only reason why it's 50 pages long is because that's the minimum number of pages that Amazon will publish. Otherwise, I would have made it shorter. Honestly, I hate long-winded technology books. Who the hell has got time to read them? So what I've tried to do is, in 20, 25 years of working in technology, just distill what I think are the most important principles, give them some contentious names, and then describe the assertions they make and where they could be applied, and in some cases where you should make exceptions for those principles, because it's not a religion, they're just guiding principles, nothing more than that. No dev is really how you deal with your development resources that you have. It doesn't mean you don't do any development, although sometimes that might be a good thing. Only engage in development projects that actually generate value for your bloody business. Now, that's probably because I worked at Deutsche Bank for 6 years. There's so many projects that we worked on which were utterly useless. They generated no value and had no idea why people were doing them. And then we'd look at how much money we wasted, and you know, the share price went down. Utterly unbelievable. Right? So be very careful. The criteria that developers and development resources, and I use the word developer in a broad sense, I include everything is development now. Everything is software, right? Unless you're actually plugging in network devices, everything's bloody software now. Terraform does your infrastructure. Kubernetes is configured with YAML files. It's all software. So in the broad term of developers, I'm really mean technologists. They're your most valuable resources in any startup organization. Far more valuable than marketing, far more valuable than everything else. So you've got to use them wisely. If your developers are dicking around doing things that aren't generating value for the organization, you're wasting your most valuable resource. So make sure they're generating value. And what does that mean? It's actually the core platform that they're working on, or things that make the user experience for the customer amazingly beautiful and fantastic. So that's no dev. We'll put it another way, if you're not in the business of IT, stop making IT your business, which is what Deutsche Bank and many other banks were doing. I don't want to overly criticize Deutsche Bank. It's all the investment banks and the retail ones as well. Okay, no IT. Eliminate IT systems that demand the attentions of human beings. Like, there are so many bloody systems that I've had to deal with where someone has taken a terrible process and made a web page around it and forced me to use it. So that is not how you use IT. You're wasting all technology resources. What you should be doing is exposing services to customers and employees, services that are easy to use and consume, not administrative functions that specialists should do. So we had, I'll call it a bank that I worked for in the past. In the bank that I worked in the past, we had something that was called request for service, also known as the project slayer. Why? This thing would take, you would go in there, on the face of it, it looks brilliant. I need these servers in these locations, and here's my budget, and here's my cost center. 6 months later, absolutely nothing's happened. 200 people need to approve it. And you're in a quagmire of approvals. And this system is not making your life any easier. 6 months after that, your project's dead. So it was excellent. In the end, I thought it was a way for senior management to control IT expenditure by stopping projects from actually working. Interesting way of solving a problem. And then no ops. So for me, no ops is really eliminating all dependencies between the application and infrastructure teams. It's the job of the application team to carry out deployments, not the infrastructure team that manages the infrastructure. I think most of us that have been in IT for over 10 years remember the bad old days where dev is throwing an app over the fence and ops is doing its best, or infrastructure is doing its best to stop a change occurring. That just doesn't work. It's never worked. Eliminate those dependencies. Empower the application, the development team to do their own deployments. Put them on the hook commensurately for making sure those deployments work. And make the infrastructure team, Matt over there, make sure that he's got the automation pipelines in place. Everything should be automated. Everything should be quality controlled in an automated fashion. And there should be no reason for someone in operations to halt a deployment, because ultimately their bonuses are predicated on the uptime of the system. So if the system goes down, their bonuses get screwed. So it's no surprise that they fossilize production. If you reverse that and you incentivize the developers and you tell them that, you know, you're allowed to flip and deploy code into production, but if it blows up, your bonuses are gone, you'll see them improve really well in terms of their operations. It's simple, honestly. And then finally, if you manage to do that, then eliminate all manual intervention. You'll never do it, but it's a bloody good goal to set for yourselves. If you get 20% towards eliminating manual intervention and implementing automation, that's a fantastic achievement. And it means your IT team is giving a massive edge to the business. If you go anything more than 20%, well, I think you're probably going to win hands down. Now, I have no idea how long I've been talking for, but I'll open up to questions. I'm sure there'll be some arguments here.
I think time for 1 or 2 questions. Oh. Now I'm coming to you.
Hi, Sam. Thank you very much for the presentation. I wanted to ask you that, let's say, for example, you do get clients, I'm sure you've come across, that might not be really willing to take such changes. To them, it might be like extremely interesting. I mean,
yeah.
What do you do with those? Sorry. What do you do with those sort of clients and such? How you convince them? That's
a brilliant question.
You're going to tell them, like, in the next 5 or 2-3 years, you're going to be more or less dead anyway, business-wise.
Yeah.
So, but otherwise, besides that, I mean, you know, in the business language.
So if I can put some context around your question, if you want to affect change in a large enterprise, like specifically, with a lot of heritage legacy IT, you have to do it really carefully. I mean, Chris will vouch for this if he was here when we were at Deutsche Bank. It's a multiple tiered approach. So, number one, make sure you fully understand and you've tested what you're doing yourself first. You have to sip your own champagne. Right? So if you have any projects yourself or some friendlies that you can work with to demonstrate that your pipelines and your automation and your safeguards and your security are all compliant and work in the small, with small organizations in your team, that's the first place to start. Go for high value, low hanging fruit. You don't go for some pet project that's worth 200,000 to your enterprise. You need something that's actually valuable, but it's still low-hanging fruit. A friendly that isn't too complicated. They don't have 400,000 cores. They've got 4,000 cores. Still a chunkable size of the business. So high-value, low-hanging fruit. Then finally, get your vendors on board. So Red Hat were brilliant in terms of creating a community, sponsoring the work that we were doing, raising our profile across the bank that I worked for, which is a big bank, it's a big global bank, and really driving the effort for change. They had our backs, so that really worked. I think the final thing I would say is community building. Actually hire a community, someone who can foster a community like this, right? Do that internally in your enterprise. It's far easier to affect change if your senior management have bought into it, which they generally will. I don't think that's an issue. I think the issue is your executive or the board will make a decision and everyone ignores them. That's far more the normal way of things working in a bank. So if you can build a community grassroots from the bottom up, high value, low hanging fruit, sip your own champagne, that kind of works.
Okay, one more up here.
Thank you. Really relevant and entertaining presentation, so thank you.
Thank you.
We went through a similar selection process and we ended up with a similar stack, except we went for Node instead of Go for now. Okay. My question is around your choice of build tools. I was wondering if you have tried being Google-based, Google Cloud Build, yes, and you have discarded it for a particular reason, because we started using it recently to migrate from Circle CI, but maybe we don't see something important that's around the corner and you've come across. Thank you.
Brilliant question. I did start using Google Cloud Builds initially, and they work really well. The team that I have are very particular in the size of the containers. They want to reduce them. Basil does that really well. Also the speed of the deployment, and we needed extra flexibility. I would say, you know, Basil has a big learning curve, as Matt will attest. Google Cloud Builds are not bad, and I think the next generation that's coming is going to be even better. So unless you really need to change, don't change.
Awesome. So thank you very much. A round of applause, please.
Thank you.
Okay, so we're going to take a break now, so please get up. We'll be back at 8:30.